oh no, you're not moving? Like you just, there we go. Whew. I'll edit that later. Okay. So the first thing we're going to talk about is the history of data. So data has been around forever. Now in the past, and I'm talking like way past, data was just measures and numbers that were collected in order to solve a problem at hand. So they would be presented with a problem, they would collect information, they would collect data to help solve the problem. In the present, data has shifted. Now we have way too much data than we even know what to do with. It's no longer used to solve a problem. Now it's literally creating problems. Now, in the past, data was mainly numbers. We would take measurements. We would look at what we were dealing with. But now, data is not just numbers. It's also audio and visual as well. When you're scrolling through TikTok, when you're scrolling through Instagram, your phone is collecting all of this data on you. It's collecting how much time you spend looking at each image. So it's like creating everything we know about you based on what you do. Now in the future, the focus is going to shift primarily to this audio-visual in hopes of making progress on artificial intelligence. They're going to want to take this data and help to improve artificial intelligence so that we can have, I don't know, self-serving robots or whatever you think it's going to be. Who knows? Now, what do statisticians do? Statisticians do analyze data using pictures and summary measurements to build data-driven predictive models. They develop methods of designing experiments and gathering data that are cost-effective and diminish bias. That's a lot. And if someone were to tell you that's what they do for a living, you would literally look at them and be like, cool, that sounds great. What that really means is they collect all this data and they interpret it and they compile it into different kinds of visual aids. Now, visual aids that you guys are familiar with would just be like graphs. Now, if you look at this graph that I have up here, it says statistics degrees conferred by level 1992 to 2015. Just so you know, I was born in 92. It's a great year. Anyways, but if you'll look, as the years have progressed, the need for statisticians has greatly increased. Okay? Greatly increased. Now, these are the statisticians with bachelor's degrees. We still need them, but if you have a master's degree, we need you even more. And PhDs are mostly just college professors. If you have a PhD in statistics, then you're probably going to teach at a college, and it's slim pickings. Now, let's start with definitions. The first definition that we're going to talk about, something is the total set of subjects or things that we are interested in studying. When you talk about data, you are focused on the entire of everything, which is just called the population. Okay? A population is the total set of subjects or things we are interested in studying. Now, when studying something, it doesn't make sense, okay? It doesn't make sense to focus on the entire population all at once. Like, it's just not feasible, okay? But there is some information that we can learn about the population. So, a list containing all members of the population is referred to as frame, okay? A frame is the list of every single member in the population, depending on what we're looking at. If we're talking about people, that would literally be the list of every single person that we are wanting to learn something about, okay? Now, a strict definition of a census is a survey that includes all the elements or units in the frame. So I want you to think about this. When you talk about the U.S. Census, it's once every 10 years. So the U.S. Census is a survey that is sent out, and everyone is required to fill it out. And it includes all the elements, everyone that they want to find something out about. Okay? And then finally, a population parameter. Population parameters are facts about the population. Since parameters are descriptions of the population, a population can have many parameters. So like parameters are kind of like specific things about the population. So if I wanted to take data on just this room of people, okay, the population would be every single person in this room, okay? Now the parameters would be like the rules, the guidelines. So a population parameter about this population would be that you have to be a senior and you have to be in M2 Elements of Statistics class with Mrs. Getz. Does that make sense? Those are population parameters. Okay? Now, a sample is a subset of the population which is used to gain insight about the population. Samples are used to represent a larger group of the population. Now, this is really important because when we talk about the population, 9 times out of 10, it is not feasible to find information about every single person in the population. So you just take a sample. A sample is a small group of it that you're going to survey and figure out the data and apply those results to the entire population. So if I wanted to come into this, she wanted in on the conversation, I guess. So if I wanted to find out information about this classroom, say I wanted to know every single person's favorite type of car, but I didn't have the means to ask every single one of you and document it and put it in, I could maybe take a sample that's a good representation of this class, ask that small group, and then apply the results and say, based on this, the whole classroom likes this the best. Does that make sense? Now, a statistic is a fact or characteristic about the sample. Okay? A statistic is a fact about the sample. So if you look back to the previous vocab definitions that we just did, a population parameter was a fact about the population. The same thing, a statistic is a fact about the sample. So population parameter is to population as statistic is to sample. And then here's a really, really, really good visual about it. So the population is the entire thing that we're studying, and it's described by parameters. But a sample is just a little subset of that, and it's described by statistics. All right. Now, we're going to look at a couple of different examples, and we are going to just determine the difference between them. So on number 1, it says determine whether the statement represents a population or a sample. So it says the heights of all kids on the soccer team. Do you guys think that's the entire population or just a sample? This would be a population. The heights of all kids on the soccer team would be a population. On number 2, again, we're going to determine whether the statement represents a population or a sample. This one says the ages of 10 out of the 35 adults at a meeting. That would be a sample because that's only part of the entire thing. Okay? On number 3, it says what is the sample of the following scenario and what is the population? So on number 3, the salaries of 20 employees working for USD 489. What do we think the sample is of this problem? Salaries of the 20, the salaries of 20 USD 489 employees. Now just be aware, notice how specific I made that. I didn't just say salary of 20 employees because it's not just employees. It's employees working for USD 489. So salary of 20 USD 489 employees, or some of you might have said salary of 20 employees working for USD 489, that's fine. Now what would the population be? What would the entire thing be? Okay, so what about the USD 489 employees? Their salaries. So the salaries of all USD 489 employees. Salaries of all USD 489 employees. Now on number 4, it says again, what's the sample, what's the population? So this problem says 45% of the student body at Fort Hays voted on implementation of a campus-wide curfew. So what would the sample of this problem be? Yeah, 45% of, and you could say FHSU student body. Now, if the sample is only 45%, what's the population? Yeah, the entire FHSU student population, or student body. All right, number 5. Is the following numerical value a population parameter or a sample statistic? Now, if you need a refresher, you can always go back up to the top of your page. Population parameter is a fact about the population, and a statistic is a fact about the sample. So on number 5, it says the average price of a house in Hayes is $200,000. Do you think that would be a population parameter or a sample statistic? What makes you think a sample statistic? The average price of a house in Hayes. So they're saying we're taking all the priced houses in Hayes and we're averaging them, and the average price of a house is $200,000. That would be a population parameter because they took every single house in Hayes and they said this house costs this much, this house costs this much, this house costs this much, and they averaged them, and they said the average price of all of the houses is $200,000. Population parameter. Okay? Number 6, is the following numerical value a population parameter or a sample statistic? So it says a recent survey of 1,500 homeowners in Hayes showed that their average property taxes cost $2,500. This one would be a sample statistic. Notice how they specified they only surveyed 1,500 homeowners in Hayes. There are way more homeowners than that. So this one would be a sample statistic. Okay. Backside. Now we have a couple more vocab. It says the first thing, a descriptive statistic is the collection, organization, analysis, and presentation of data. Descriptive statistics is the collection, organization, analysis, and presentation of data. And we have some examples just right down there. An example of that would be a frequency distribution, which you guys have learned before, but we're going to learn again later on this unit. Measures of central tendency, which was mean, median, and mode. Measures of dispersion, which is range, variance, and standard deviation. Those are all numerical representations of data. Okay? Now, another type of statistics that we're going to talk about is inferential statistics. The object of inferential statistics is to make reasonable guesses about population characteristics using sample data. So what this is saying is there are two different types of statistics. Okay, we have descriptive statistics and inferential statistics. Descriptive statistics is not going to be used for any decision-making purposes. Descriptive statistics is just that. You're going to collect all this data and it's going to describe what you're working with. Does that make sense? That's why it's got mean, median, mode, range, all of that. It's just describing what you're presented with. Inferential statistics, on the other hand, is going to be used to make assumptions, to make decisions. It's going to say, here's the sample data, here's what we know about the sample data, and you're going to take that information and say, based on this, I can assume this about the population. So descriptive is used to describe, inferential is used to make decisions. Does that make sense? So, knowing that, let's look at these examples down here. A heart researcher is interested in studying the relationship between diets, which are high in calcium, and blood pressure in adult females. The researcher randomly selects 20 female subjects who have high blood pressure. 10 other subjects are assigned to a diet with a standard amount of calcium. After 1 year, the average blood pressures for subjects in both women will be measured and compared to decide if diets in high calcium decrease the average blood pressure. We have 4 parts here. The first thing they want me to do is identify the population. What is the researcher really wanting to make a decision about here? Adult females. The population is the adult females. Okay? Part B, what characteristic of the population is being measured? What is he trying to find something out about? Their high blood pressure. So we're going to say that the characteristic that's being measured is their average blood pressure, because not all of them will have high blood pressure. Okay, now the sample is just the small group that he's measuring here. So what would the sample be of this problem? The researcher randomly selects 20 female subjects who have high blood pressure. So the sample would be 20 females with high blood pressure. That's a good question. Studying the relationship between diets which are high in calcium and high in blood pressure in adult females. The researcher randomly selects 20 female subjects who have high blood pressure. 10 other subjects are assigned to a diet with a standard amount of calcium. After 1 year, the average blood pressures for subjects in both groups will be measured. I would say, yeah, I would say it would be 20 or 30 females, because they said randomly selects 20 female subjects who have high blood pressure and 10 other subjects. Oh, nope. Okay, no, it is 20, and here's why. These 10 other subjects don't necessarily have high blood pressure. They're the control group. He's saying they're just going to be on the same thing, but nothing's going to change about them. All right, and then part D, is the purpose of the data collection to perform descriptive or inferential statistics? So are they just wanting to collect data to figure something out, or are they wanting to make changes with the data? They want to make changes. They want to make improvements. So this would be inferential. This would be inferential statistics. Yes? I mean, descriptive is to help understand, but like you're not going to make any changes based off of it. We're going to do some descriptive experiments later on this unit that will help you understand. All right, so number 2, heavy, episodic, or binge drinking is a serious problem in colleges and universities in the United States. A study reported in the Journal of the American Medical Association surveyed a total of 17,592 students selected from 140 four-year colleges in order to examine the extent of binge drinking. The study found that 44% of the students surveyed admitted to being binge drinkers. A binge drinker was defined as consuming 5 or more drinks in a row for men or 4 or more drinks in a row for women during the 2-week period or prior to the survey. What's the population? College students? How many of them? That's how many they surveyed. But so that would be what they chose, but what are they wanting to learn something about? Binge drinking in who? How many college students? That's how many they surveyed. All of them. All of them. So students in all, Kiana, students in all colleges or universities across the United States. Students in all colleges or universities across the United States. That one's a little tricky. Don't get caught up in the numbers when talking about the population. The population is what they're trying to learn about. And they're trying to learn about binge drinking in college students, and that would be all college students. What characteristic of the population is being measured? What are they learning something about? Binge drinking. So the characteristic would be the proportion that binge drink. The proportion that binge drink. Now this is where we want to get a little more specific. When they say identify the sample, what did they sample? Yes, they sampled exactly 17,592 students from 140 four-year colleges. And it's important to put that last part because if we just say 17,592 students, like elementary students, high school students, they were very specific. They selected these students from four-year colleges, and they selected them from exactly 140. Sometimes when you are answering these questions, it's easier to actually identify the sample before you identify the population because they're so specific about it. Sometimes it's a lot easier to say, okay, they specifically surveyed these students, that's my sample. What are they trying to learn something about from that? All college students. Now part D says, what are some problems associated with the collecting the type of data described in this problem? Now this is something that you guys really need to think about, and it's something that we're going to be addressing a lot this year. So what are some problems associated with collecting the type of data described in this problem? I want you to think about this. Like, don't you guys take a survey every couple of years, that really, really long survey? Yeah? What are some problems with that survey? It could be inaccurate. Why could it be inaccurate? Like, what are some reasons that this survey wouldn't be accurate? People don't care about it. People could lie. Sometimes it's super long and you're like, oh my God. So do you think that's a really good representation? No? Are there any other things? Check this out. I said, first of all, the data depends on students' honesty rather than concrete measurements. That's a big thing. When you're asking people questions, you're depending on them to be honest, and sometimes that's not accurate. But the other issue is the sample only specifies a 2-week period. It says a binge drinker was defined as consuming 5 or more drinks for men or 4 or more drinks for women during the 2 weeks prior to the survey. Depending on when this survey was given to the students, that might not be accurate. What if the survey was given to students during finals week? And those 2 weeks before finals, students were really studying and there wasn't binge drinking taking place, but the rest of the semester maybe they did indulge in binge drinking. That's not accurate. So 2-week period is not an accurate time frame to get realistic data. So something that I hope you take away from this lesson today is whenever you see surveys presented in media, you are constantly asking yourself this question, like, what's wrong with this survey? Because there's always going to be faults with survey. And if whoever's presenting the results doesn't address those concerns, then they're trying to hide something, and that's really, really important. All right, let's go to number 3. A nurse is interested in the growth curve of boys from infancy to the age of 18. 1,000 boys are randomly selected, and their heights are measured at various intervals from birth until the age of 18. Based on these measurements, growth curves are constructed based on the percentage of heights observed to be at or below a certain height at each interval. What is the population? Okay, so all boys under the age of 18, right? Because from infancy to 18, same thing. All boys under 18. Because 1,000 is the sample, but they want a growth curve for all boys. 1,000 is what they're pulling out. Population is what they're trying to figure something out about. Ooh. They didn't specify, so I would just say all boys. If they specify, that's a good thing to notate. Now, what are they trying to figure out? What characteristic of the population is being measured? Okay, so I put percentage of boys' heights observed to be at or below a certain height. Same thing, fine. Now the sample is what they are specifically pulling out. Like think about this. It wouldn't really work. It wouldn't really make sense to take every single boy in the United States from infancy to age 18 and calculate all of this information and compile data about it. That would be absolutely asinine. There's no way that they could do that. So instead, they only looked at a sample. What was the sample? 1,000 boys. Because if you say, I want all of the data on every single boy in the United States, whoever is in charge of compiling that data would be like, no way, absolutely no way. But then if you come back and say, oh, okay, that's not realistic, how about 1,000 boys? That's better. Now what they're doing is they're creating a growth curve. When you have a baby, you take your baby to the doctor and they measure them, and then they show you like a graph. And on this graph, they have all of these growth curves or whatever, and they're saying your baby is right here, which means that they're in like the 50th percentile. And we're going to talk about what that means later on, but that's what they're trying to do. They're trying to find these growth curves to let you know how your baby or how your child is measuring compared to others. Now finally, is the purpose of this data collected to perform descriptive or inferential statistics? Descriptive. They're just trying to describe where your kid's at. Descriptive.